Woohoo, we're live. This is take 2 with Math 40, Elementary Algebra, Chapter 1, Section 1, an Introduction to Algebra. I'm redoing this because I had a comment on the previous version and it said that it was hard to read. Let me turn on the light, get a little more light on it. I have actually made all of the text a couple sizes bigger, so hopefully this will be easier to read. But I want to also remind you, I'll get all these things out of the way. Let me remind you that I've posted all of the notes. So these notes are available on Canvas and in the Google folder. And you can find those links in the introduction email, or you could just ask me and I can get you the links for those. So you should see these in Canvas. So you will see this blank sheet, and then I will scan what I write in, and then I will post that as well. So you'll be able to see the scanned notes, you'll be able to download them, and the blank notes in case you want to download them and use them to take notes as well. It's up to you. Okay, so here we are, take 2. Where does the word algebra come from? And I think it's really important we focus a lot on Greek and Latin when we're doing math, because a lot of Greek and Latin was used in math, especially in the later development of algebra, the algebra that we're teaching in this class. But originally, the term algebra does not come from Greece or from Rome. It actually is a Persian word. It comes from Arabic. This is, and I can't confirm, I got this off Wikipedia and I believe it, this is the name of that first book where there was a mathematician slash scientist slash poet slash a bunch of other things named Muhammad. And there's the rest of his name, which I don't have the correct pronunciation on. I apologize. But around 820 CE, and given that I'm recording this in 2020, this is 1200 years ago, he sat down to write out what was the beginnings of algebra. And this got shared all over the world. This went far and wide and was the beginning as far as anyone can trace it back. I don't know who was helping him write it. I don't know more about the his teachers or their teachers and what they were doing, but he is generally remembered as the person who started this whole thing. So if you're looking for someone to blame at 3 in the morning when you're frustrated with your homework, there's the book. And back then, and continuing to relatively recently, most math was done through letters. People would write each other letters and they'd write math and send it off. And that's how math was developed. People would write books, they'd read the books, but basically most of math was communicated via written symbols. So what we're going to start with is the symbolism of algebra, and to make sure that we're very clear on what all of it means. Because what you would do is you write down the math and you would send it in a letter off to your friend in, say, Germany, who's also working on algebra. And if there's no telephone, which there wasn't, for the first 1100 years or so of this, 1,000 years, you have to trust that your letter got there and the person at the other end understood what it meant. So we've got some very specific symbolism that we use to express what we mean. The first 3 symbols that I want to talk about, and I'm hoping that you've seen these before and that this is just a refresher, but in case this is brand new, these are called grouping symbols, all 3 of these. And they are used, grouping symbols. Hopefully that's nice and big and you can see it more easily. All 3 are used to express when you want a part of your math, your algebra, to be held together, perhaps approached first, or be seen as special or having more priority than other parts. So this is for grouping things together. parenthesis or parentheses. This is the singular, this is the plural. This is a Greek word, which is why you may not be familiar with the singular and plural. Parenthesis, parentheses. Fun fact, there's also something called an axis, an axes, which takes a plural form in the same way, also a Greek word. So these are these guys. And sometimes people call them round parentheses to really emphasize that they are these ones, as opposed to the bracket or brackets, sometimes called square brackets, which look like that. For the most part, in a lot of cases, these are used interchangeably. If you get up into higher math, these will have specific meanings, other meanings, which we're not going to worry about right now. But if you do continue to study math for years and years, you will get to that. And you'll look back and go, oh, I see what you were saying. Now, brace and braces these are some of the hardest to draw. They're these guys. And they kind of look to me, they're all pokey and bent. And so they kind of look like the kind of braces you wear on your teeth. Right, these guys. I know, now with visual aids. This is what braces used to look like when I was little. They don't really look like that anymore. But, you know, braces. So these kind of look like braces that go on your teeth to me. And again, these are just another way to set aside to say this part of the algebra is held together and especially important together. Pardon me, there's a little bit of smoke today. The next symbol or word, vocabulary word I'd like to go over is the word operation, which, yes, has a lot of meanings in English. We're going to go for one of the more basic, one of the older meanings, which means it is an action. It is something you're going to do. And specifically, we're going to focus on addition, subtraction. Now, multiplication is interesting. Multiplication. Hopefully you are familiar with the idea that multiplication, as you go further on in math, no longer looks like an x. That is because we're going to start using x as a variable and it gets too confusing. So there's one setting where we use an x for multiplication. That'll come up much later, but I'll show it to you and you'll go, oh yeah, I see, okay. But most of the time we're going to switch to this closed circle. Make sure it's all filled in. An open circle means something else in math. And then there's also division. Now, division is kind of tricksy because in algebra, you'll almost never see the division sign. We are actually going to sneak division in using fractions. So division usually shows up not like this, but like a fraction. However, there's division. I want to point something out when we talk about fractions, like if I pick the fraction 2/3, I want to look here if they're not too small. That division sign and this fraction, can you see how they're a very similar symbol? This almost is like there's something on top, something on the bottom, and a bar in the middle. And here, this is something on top, something on the bottom, and a bar in the middle. It's kind of interesting that they would be related, huh? Okay, so that's the first page. Now, with it being so big, we're going to go through pages, just page. So I apologize. I'm going to be flipping pages. It could be a flip book. Next up, a variable. This is a symbol whose value changes or can change. So this is a symbol we're going to use to represent an amount that we either don't know, or maybe it's an amount that could change, something we're looking for. And so the most common ones are x, y, and then you're going to see me do something funny with my z. I cross my z. You're not required to cross your z. Some people do, some people hate it. The reason that I learned to cross my z's is that as a teacher, I want to make sure I'm clear. And my z's looked a lot like my 2's, and I didn't want to confuse students. So instead of confusing them, I annoy them, and I apologize about that. That was a choice I had to make. You do not have to cross your Z's. X, Y, and Z are very common here. And for my class, not necessarily other people's, but I would encourage you play with other variables. For example, happy face. Now, honestly, most classes don't recognize happy face as a variable, but I think it's a great variable. Flower. Now, this is starting to get pretty complicated. I mean, X is pretty easy to draw. A flower takes some time, so you may not want to do that. If you've got a bunch of them to write, this is going to take you time. The trick about a variable is it has to be clear. It has to be something you can repeat. And it has to be something that other people would recognize. Like you can't like use a flower here and then a different kind of flower to be the same thing. You have to write it exactly the same way every time. Because of this, like a picture of, say, the Mona Lisa. And yes, those of you who are watching, she's kind of got her arms folded and there's like hills in the back and like some sky or something. I don't remember. I think there's a table, but I don't see. This is how well I know the Mona Lisa. There we go. The Mona Lisa, not a good choice because it takes a lot of time to draw it and it's hard to draw it the same way. So I would say don't use the Mona Lisa. Use symbols that you can write easily. If you want to start playing with Greek letters, go for it. Alpha, which looks like a little fish, is an excellent choice, as is theta, because theta is nice and easy, and it's a Pokemon. You got it. The Greeks were playing Pokemon. I didn't even know it. So any letters you want to use, if you want to use Cyrillic, awesome. If you want to use characters from an Asian alphabet, go for it. The only thing I'm going to ask is if you're going to use something that you think might be more complicated than I would recognize, that you just show it to me and introduce me to it. As soon as I've seen it and I understand it, we're golden. Other note, because of the possibility of confusion, avoid the following letters. Oops, not letters. Let's try that again. As variables. E is a constant. E is, and here's wiggly equal signs, means approximately 2.7 with some other numbers there. I is the imaginary constant, and we don't get to study that in this class. We will learn it. You will learn about it in Math 60. The letter O looks like 0. So that's a problem. And the letter L, now the letter L looks like a 1, but if you draw it in script, in cursive, you draw that little loop on top, it looks more like an L. So this can be confused with a 1. This looks more like an L. A lot of times when people use L's in algebra, we use a cursive L. Okay, so just some thoughts. And if you have any questions, you can always ask me, ask other people, ask lots of people. A constant is a symbol whose value does not change. And one of the easiest constants is the number 2. If I write this symbol, you know I mean this many things. It's 2 things. If I write this symbol, you know it means this many things. If I write this symbol, if you've had geometry, you know that I mean pi, which is about 3.14. Believe it or not, E is a constant. I is a constant. You may not have studied these at all yet. And then you can also and it's kind of weird, but sometimes even a symbol like X could be used as a constant. Now, I'm sure you understand that we would be very careful about that because it would probably confuse people, but it's possible that X could be a constant. So that's just something to tuck away for the future. If you're asking me, which I hope you would, how the heck do I know what's a variable and what's a constant? The answer is, well, I'll tell you. we'll figure it out. When we're doing math together, you read the problem and it'll tell you which ones are variables, which ones are constants. And if it's not clear, let's talk about it. Next up, algebraic expressions versus algebraic equations. And it looks like my cats or something have been getting at the paper here. That's exciting. So algebraic expressions versus algebraic equations. An algebraic expression is a combination, some combination of addition, subtraction, multiplication, division, variables, constants. So it's something like 2x plus y. That would be an example. Over here, an algebraic equation is addition, subtraction, multiplication, division, variables, constants. And the big difference here, and let me get out my handy dandy yellow highlighter, because the big difference that makes this an equation is the use of an equals sign. So if I said 2x plus y equals 5, the difference here is that this is a complete thought. This has a verb. It says equals 5. This is just 2x plus y. You're just talking about a character in a story. This is, you're telling everybody what the character does. So I think I'm going to peek ahead. I think what I'm going to do is I'm going to cut this video off now and go ahead and break this into a second video. So this was the first part. I will stop here, and then the very next video will be the next 2 pages of 1.1. Okay, woohoo, we made it. Version 2, take 2, hopefully a little easier to see. Let me know. And woohoo, math on. And I'll see you in the very next video. Woohoo.